Okay, let's move on to the final step, which is making the HLS backend. And one possibility that I thought about is whether we could maybe reuse the current code generator. I mean, it has. I mean, it looks long, but that's not really the problem. The main problem is that I really would like to separate out reference counting C backend and non-reference counting C backend. It's just a matter of convenience. The one that I have now, I think is already compiling to like 2 different platforms. I have the prototypal one, which is just pure C, and the upman C kernel is what the Python backend calls in the upman Python backend. So let's just clean house. I mean, a C++ backend is not the same thing as a C one. And I mean, even though we'd be using macros for most of the things, there will be some differences probably, even though we could, paper over them. Right? I don't want to have to deal with having reference counting code in a backend that shouldn't have it. So we'll copy paste this and then get rid of it. I mean, get rid of all the reference counting stuff. I put it up here. We need it down here. Cogen CPP HLS, or maybe HLS CPP. Okay. And then I call Alt and press the down arrow to copy it down here. Great. We'll also give it its own namespace, HLS CPP. And great. And we don't need the backend type anymore. We'll just import string h, even though I'm not even sure whether the actually the way the HLS backend works is actually it doesn't have too much FPGA specific functionality. All the code it compiles is actually compilable to the CPU as well, and that's how you can create the test benches, which are just the unit tests for whether the program works as expected. The thing about FPGAs is that they have absurdly long compilation times, like hours and even days. So having test benches is essential for shortening the time it takes to test the program. So far we've been doing it, we write something, then compile it, then test it out by hand, but I don't think that kind of method will work on FPGAs. And in fact, the compilation times are the thing that I'm most afraid of when it comes to programming FPGAs. It may turn out that this will be the thing that will kill me this time around. Not so much the lack of computational resources, but the time it simply takes to program them. Okay, it won't have the int32 return, but the void one. But what the main will have this time are function arguments. We'll leave those aside for now. Never mind that one. Let's just I think it's still expecting. Okay, let's get rid of some of this stuff. In fact, when it comes to sizes of the variables, the FPGAs actually have the variable size integers, some kind of AP int type, which takes in the bit size as an template argument. So instead of using these byte sizes, we'll convert them to bit sizes. Alright, this should be 16, this should be 8. And this should be what? The rest should be. And let's make it 64. We don't have any reference counting utilities. They should be all in the C backend. Okay, we'll gradually start removing stuff. Is heap, we don't need that. Is string. I mean, we'll have everything we need in the other backend in case we need to return it. Okay, this is the reference counting passes. These are the reference counting passes. I'll get rid of these. Term variables. Those are just literals and runtime variables. Finds last data. Oh, this is for printing the C literal. Malloc free. The Appleman device had a bit slightly different malloc and free. It uses the body allocator, which is some kind of different thing. It doesn't matter. Yeah, we don't have the reference counting anymore, so we don't need to print the decrefs for declarations, globals, unions. Pre-pass. Code general environment. String return. Oh, it's not this. I used to have a known reference counting backend years and years ago in the CUDA backend for the old Spiral, but this one is a better reference. There isn't actually much reference counting code being produced. It's all here. Here are the decrefs and the increfs, and they all get printed at the start of each statement. Once we get rid of this, that should be it. Oh, here are the ref counting changes. Oh, we can get rid of this. Oh, where's the op? Op should be somewhere below. Oh, the literals here. the string, the C string. Okay, we'll change that. We don't need this stuff anymore because the string is just there for our convenience. Find start. Oh, the graph. Print the graph. Okay, where is the string? Let's go. We don't need this anymore. This should just be a character pointer. Yes, the lit string should be fine. I mean, we cannot just drop the string row because it might have, you know, the N, T, or R. These characters need to be handled especially in the printed code. I mean, I'm just adding an extra slash so it gets printed correctly. We'll get rid of the reference counting variables here. Oh, the decrefs also get printed at the start of every match case. What is the default? Okay. Oh, I don't need a C quotient to be dominant. I mean, to be pinned. In fact, we'll pin it, but to the right. Let's close all but pinned. Where I had set empty. Dictionary key. Okay, necker. Oh, where is this QS? One thing that the reference counting pass is useful for is getting rid of unused variables. So we won't have that. So it will always destructure every field of the union every time. But I mean, since that doesn't do any kind of allocation or the allocation, the C compiler or the C++ compiler should be able to take care of that. I think that the Xilinx HLS C++ compiler is based off GCC. That's the way I gathered it. In truth, for something like an FPGA, maybe a different fundamental language would be a better fit. In fact, it would certainly be like that. And yeah, maybe, but yeah, at the same time, you also can't deny that having it compiled to C++ is useful because you get access to many of its libraries. So who knows? But with the Spiral on top, it will be much better yet, because at the very least, Spiral has a lot of powerful features, such as top-down type inference. It also has the very powerful bottom-up partial evaluation pass that can do pattern matching on types directly. It has type classes, Haskell-style type classes. In the language, we call them the nominal prototypes. And yeah, that's all that comes to mind right now. I lost the thread of thought. Yeah. I mean, did I mention the functions? The functions are one of the most powerful things, because you can inline them in Spiral. You can do a lot of more composition that you couldn't do in C++, for example. I don't know whether the C++ compiler has like capability. It very well might, but using functions in C and C++ is simply abysmal. It has the worst syntax of anything that I've seen, especially function pointers. Function pointers in C are even worse than arrays, if you can believe that. Okay, let's move on. The error create should just be a statically typed array. The error literal. Okay, let's leave this as so for now. I think I got rid of his string. I meant to pin the C backend. Let's just put this back in. Now it's type checking everything again. Or wait, what did I do? Use heap. Okay, these are just some considerations for reference counting the join points inside the while loops conditionals. There are various methods that can be used to do reference counting, and in particular inside the bodies of the while loop it's a bit different than in normal methods. It doesn't matter right now for us. Closures. I think closures should be erased completely because we simply won't have them. At least in the Qt backend we had function pointers, but it seems the HLS backend doesn't support even that. So, meh. But you know, I'd at least want to be able to get function pointers just in case they get allowed in the future. And some constructs like tasks do get closures back. So yeah, we do in fact need closures, just not all of this trash. Oh, this is the closure create. I think these domain arguments should be empty. Let me think. Closure I, struct closure I. The reference counting. Let me pause for a bit. Okay, I got some intuition. These domain arguments are in fact what the partially applied arguments to the closure should be. Or no, these are the real arguments actually, sorry about that. And the domain, the closure in closure I, the closure environment, oh yeah, I think these are in fact the environment variables. Yeah, the way it goes is that we have the integer that keeps track of the reference count, then comes the pointer, then come the environment arguments. They get printed below the function pointer. And then if it's created, closure method, it how is the closure create? I need to understand this. Closure create, and then this should create the environment. And these, yeah, these end up being the arguments for this string. And these are the free variables, x free vars. And these are the arcs. Okay, I see. Okay, we need to do. Okay, let's get rid of the reference counting code. That means this, the graph body, we don't need this. We don't need most of the closure create, but we do need to make at least a type def, something like type def closure with the type of the. Wait, what is this fun tag? cfun domain range. Just a second. Oh yeah, this is what the closures get upcast to. These are just closures without the environment arguments printed below them. Let's get rid of it. Then let's just start a type def, and then we'll align s type sprintf. Then we'll start off with a type def. Then we'll start with the range of the function. Oh, where is the range? How do you get the range? Okay, this is how we get the range. Tuptai range. Well, let's get the tag. We're passing the range here. We don't need even the sprintf. Let's use an interpolated string x range. Let's make it pointer closure I. And this is the shitty function syntax. Then we need the domain arguments, and those are the free variables. No, those are not. Those aren't. But instead, what they are. No. They are the domain arguments, domain arg style. Oh yeah, the way to get them is by using this. Let's try this. And then we'll just okay. Oh, wait. Okay. I'm just making sure that what is the F-sharp versions of the interpolated string have these mod S and mod I signs before the braces in order to do the type checking. For example, if I did I, I'd get a type error on the range, but with an S, it type checks it properly. Okay, this is not bad. Now we have the right function pointer being printed, and in fact maybe I shouldn't have got rid of that cfun thing, because we'd also want to, you know, convert them to a function pointer. Oh yeah, we need function pointers, definitely. I mean, I did need them in the CUDA backend in order to interop with the C++ libraries there. You know, you'd have something like a reduction function in a library, and you need to pass in a function pointer in order to make use of it. I don't think, I'm not sure how the HLS compiler supports that. I'm not sure if it does. I mean, if it doesn't support lambdas, then going from the C++ compiler to Spiral will be a big step up in usability. Okay, we have this, and we do need the cfun. Show me the cfun. Is this thing here? Oh, this is how it was done. We want to print the same thing as here, except it should just take account of the domain and the range domain args die. Okay, I need to, yeah, it's the same thing as before. Let's comment this out. Oh, the domain args die is the same thing as here, I think. And then do I need something like fun I? Oh, it's not completely the same thing. It has different arguments. X domain args die. Oh, I see. It's a bit different here. Here's the magical partial application. Let's do a little change in the C backend. We don't need to do it like this. Instead, we can just omit the argument. By the way, don't try doing this in JavaScript, otherwise you will run into all sorts of issues. JavaScript is really weird. In JavaScript, this argument can refer to pretty much anything, unless you use the newer lexically scoped lambdas, which are something like this. The function scoped lambdas, those are trash. They're not good for anything. It's just a thought. Okay, we have this. Right now I'm thinking whether I should raise the type error here or somewhere else when it comes to, okay, if let free wars, okay, let assert empty. If array is empty, x then equals false, then raise codegen error. The HLS C++ backend doesn't support closures, only function pointers. It needs must not have any free verse. Okay, wait, and then else x, it should return. I'll do it like this, something like that. Oh, the tuples. Yesterday I spoke about maybe using the default C++ tuple class for this, but I want to retain the flexibility of compiling the tuples in any way I want. I'm not sure whether the C++ class would order their fields, for example. And I already have the the destructuring code and the tuple creation code implemented, so I don't want to mess with this. I might have to remove this static, but that's fine. Let's move on. Let's not think about this too much. I already did that. This is assigned immutable. Spiral has what is called the layout types, which are just records and mutable records. And these assignments are where... Was this for tuples or something else? Sorry, I had to take a break. Let's resume. I remember this is for mutable assignments. In those we need to do the reference counting operations. Since we don't have reference counting, we can get rid of this. Same goes for assigning to arrays. Oh, the layout types. I mean the layout types, we shouldn't even have them. The mutable union. Okay, we have in Spiral we have recursive unions and the regular ones. The recursive unions will have to get rid of them, but for the regular ones they'll stay in. They don't need the ref counting thing. Here are the cases. We'll factor out the is stack. If x is stack, stack arrays, actual arrays, recursive unions aren't allowed in the HLS C backend. Do them needing to be allocated. For them to be converted to Print ref C, reference counting. Oh, we don't need the reference counting. I mean, in case you're wondering why the regular unions would need reference counting, it's because they might have other heap allocated structures inside of them, but that won't be the case in this backend. The graph in graph. Oh no, what is all of this? Oh yeah, I think these are the functions to create the individual cases. And then we don't need this since it has malloc. Okay. This just prints out all the tags for all the cases. I mean, this prints out all the cases for a particular union type. Oh, not bad. And instead of doing that here, only just do this, and the U stack. What's going on here? Oh, not bad. Oh, the array. This is the ref counted array. Arrays will be just regular function pointers in this backend, so we don't need them. Okay. Now we have lowered the amount of code in the backend quite a bit. This one is now 560 lines, and this one is nearly 1000. Okay, now we have to take care of the other cases. This should be something like tuple tie a. Would something like this work? Oh, the heap and mutable types. Oh, what is this to do? I have no idea. Maybe I already fixed it. Who cares? Oh, this needs its own special error. Oh, okay, I see. Oh, this is how the functions work. And yeah, this is the same thing that I consider doing with the statically annotated arrays, because it's much easier to have the type annotation just on one side. Okay. Oh, method while. I think I got rid of that. I think. Just a second. Did I really get rid of it? I have just the method. Okay. So yeah, I don't need the template. I can just fold that in, get rid of it. Method while. Heap mutable set, layout to heap. All this stuff should be errors. Okay, we'll do the errors. Raise cogent error. Cannot create a heap layout type in the HLS C code gen backend, actually, due to them needing to be heap allocated. Cannot index into a heap layout type in the Okay, the same goes for this one. Heap mutable set. Oh, why is this giving us? Whoops. Okay, and then cannot set into a value into a heap mutable type to the error literal. It's basically just an array, but with a, int something like that. I'll have to do that here. Okay. Oh, these are the arguments, I think. but they're also wrapped on like 2 times in these curly braces. Oh, that might be a mistake. I think them being wrapped 2 times is a mistake. I don't think I ever used the array literals like this. Oh no, wait, this is an interpolated string. My bad. Everything's fine. Oh no, this is an error I create. And this is a harder operation because honestly I don't know how to do it right here. I just do an error, raise cogen error, use a error I create. Oh, not. Use a macro to something like int b. Yeah, I mean the hardware definitely won't have exceptions. Okay, raise valid. Oh, this is applying function pointers. I don't think that this will be possible. Function is not supported. As I said, or rather, the way I've read in the documentation is that it doesn't support function pointers, but constructs like tasks do receive them as arguments. So it's a bit iffy. Actually, let's try supporting them for now. I'll leave this like so. Comment this out, and then right, it's in the other C backend it's passing itself as the first argument into itself. But in here we just need this one. let v, and then I can make it even shorter, like this. Array length, array string length. Array container, array maybe I could print that. Maybe I could do the string length, but seriously, nobody's going to use a strings in FPGAs, so who cares? Maybe I could, import string h and do string len. Oh, why not? Listen. String len C++. High links. User guide. HLS. Okay, let's do a little tour through the guide to see what it says about strings, data types, pointers. Not this. HLS libraries reference, math print, precision data types, task, vector. What is the migration? Okay, if this is possible, somebody correct me, but I'm 99% sure that the HLS backend, I mean the C++ libraries for the HLS backend don't support the strings, so we won't be supporting it here. Okay. Oh, this is indexing and setting from arrays. This can be just a regular thing. Assign array. And this is all that we need. Let's get rid of all of this. Oh, there's the string index. Okay, we can support that. No, why not? string compare. This is the same. This is the same string. This is the same thing as string length. We just want to support it. As you can see, the backend itself is doing quite a bit of type checking, and this is normal for languages with partial evaluation. Though it's not like I know any other language than Spiral. This is just sorting the fields. In the future we might have to add some hacks in order to support the types that have fixed arbitrary sizes. Oh wait, we have some red here. Oh, okay. This should be okay. No, what? Yeah, the only thing I'm confused right now is how the closures are created. There should be something for those. Closure. Where is the closure called? Layout rec. We don't need this. Where is the closure? Oh yeah, here's the closure create. Okay. This needs to be done a bit differently. Maybe it needs to be printed as closure method I. And there should be no arguments. Closure method I. No, then what? Let me put a bookmark here with the Ctrl KK, and then where is the closure? What is this thing doing? Yeah, it's rinse a method. Yeah, I think I went a bit too far with erasing stuff. I should at least be printing the method of the closure. It should be in here somewhere. Closure decref body, closure method I. Okay, is this thing here? Okay, it should be the domain args type. Okay, something like this. Alright, right. It's not the same as. Okay, let's do domain args. Then this thing, range II, we don't need this part, we don't need this part. Okay, then it indents into it, 3 wars. Oh yeah, this is where it destructures the closure inside the body. We don't need this since the closure won't have any free wires to begin with. I should just get rid of this. We can do some factoring here. Arcs. I think this should be fine. Let's just take a look at the other side again. And the only thing we're doing wrong is actually calling anything here. This shouldn't be happening. The arguments in the closure should be empty. I wonder what this is for. I see. Wait, but is this really correct in the C backend? Oh, right, it is. I mean, when it's not a printer for the string, but for the lit string. We have the lit string, and we should have another place where it's printing the raw string. Yeah, here is where the literals are printed. It would get printed as a string lit, but over here we want them to be printed as raw arrays. I mean, not here, but here. Yeah. And this wouldn't end up doing any heap allocation. It's just a small optimization. No problem. We can get rid of this. Layout index. We don't have the layout types anymore. We can hide this. Oh, C array, C string. We don't need the dictionaries for these anymore. No, what's this? Oh yeah, we don't need this. Yeah, I think they should do it. I mean, if this plan works, probably Spiral will become a FPGA specific language, so we won't even be needing the F# or the Python backends anymore. The way to interop with it in the future would then be, I can very easily add some functionality into the language to create wrappers for all the FPGA functions automatically, and that would be pretty convenient. I mean, okay, when I had the Python backend, I imagined that the way the AI chips came out, they would be similar to GPUs. I mean, you'd have some kernels, you'd compile them just like that, and the Python backend would call them as it went along. And GPUs are pretty fast to compile. They aren't any slower than CPU code. But the FPGA code is extremely slow, so the way FPGAs will be interacted with will be much different than any of the other devices for that specific reason. Who knows? I don't know what the future will be like. I expect the AI chips. Now I've discovered FPGAs, and I see this as an opportunity. But who knows? Maybe by some miracle, the AI chip companies will come out with something useful. I'm not expecting anything at this point anymore. Will that LK99 superconductor turn out to be true? Maybe in a few months' time. It's just a dream, much like AI chips or memory stores. I'm completely lost in this kind of world. The only thing I can do is keep putting in effort. Now, let's move on to testing. We have the HLS C backend. And what we'll do is add them. In the supervisor, a message gets sent to compile the code for a particular backend. We don't have the Python backend anymore. We have the append Python plus C, Python C F#, and we'll just add one for C++. Oh, what did I do? HLS C++. CPP HLS CPP and this is all that we need here. I'm actually surprised that it says that the Python backend has been replaced with in the version of 2.4. I think the 2.4 is just what I did recently, and what I did in late 2030 is 2.3. Created a Python backend. Where did I remove it? Oh, okay. Let's make some changes. We've done everything that we can on the .NET side. Now we'll go and modify the plugin here. First we'll go into the package JSON. Now where are the backends? HLS C++. We'll move Python up here. Now, do we need anything else? Yeah, I don't think we do. I think this is all that we need. Okay, let's give it a try. But first we need to publish it. Alright, this is now returning an int32, but the backend should be a void. Oh, just a second. It's a lot easier to navigate in Visual Studio Code compared to Visual Studio. It really lacks a lot of quality of life conveniences. For example, I can select all of this, press Shift 9 to open a parenthesis, and it will erase it. It's pretty lame of it. In the HLS C++ backend should be a unit type. And to be honest, this latest change will make things very annoying, because I mean all the F# tests, all the tests, because the C backend requires an int32 to be returned, returning int32, and now we have this. And this is a kind of an annoyance with having multiple backends for a language. It's really, it's the same goes for array index sizes. In .NET you are indexing using 32-bit sign integers, But the Cython backend required 64-bit integers that are, I think, signed but could be unsigned. I mean, C is kind of really confusing when it comes to what the sizes of our particular data type should be. Okay, let's try testing it out. Spiral, HLS C++, and it's no longer a TCP port, but just a port. Alright, I'll have to, let me do some changes here. HTTP port. Okay, now let's try compiling it. Wait, I think I set. Yeah, I set it correctly. Let's build the file. And it's telling me that it isn't for some reason. Oh, wait. I have it all wrong. The unit type isn't a variable. Should be a void type. Let's make it a void type. Then we'll publish it again. Okay, yeah, it's the same thing as before. I'm a bit distracted right now. Let me just pause for a bit. Okay, I had a bit of time to think about it. Let's make a new test. We'll just copy this one. And let's call it HLS CPP1. Okay, this has the packages main. Okay, it has nothing in here. Let's just copy this into it. And do we want it to import the core packages, core, and inline the entire thing? Okay, this is the HLS CPP. Now let's compile it. I mean, build it. What I want to do is maybe test a few things, and then we'll wrap up this video, because we've in fact implemented the backend. I don't think there's much chance of there being bugs, but if there are, I can always just, you know, fix them on the side as I go along. I just want to test out whether the closures work. Okay, let's get rid of this. Closure F. Let's see what this gives us. Closures must not have any free variables in them. And this one shouldn't have any free variables in it. I think I'm probably not checking it. Whoops. I got the conditions the wrong way around. Not this. TypeScript again. TypeScript is messing with us all the time. The type of this is unit to unit. Oh, now what is getting generated? Yeah, here's the function pointer. Here's the closure. I mean, do I even need to print this out? Closure. Yeah, what's the point of this? It would never get used anywhere. Let's publish it again. Yeah, now we just have the function pointers. I mean, they're pretty troublesome because they need, if I wanted to write them in here explicitly, no wait, it should actually be something like this, not without, not like this. There's something wrong here. Fun. Why fun? Is this how it's supposed to be? Oh yes. Or I think in the C backend, these function pointers are actually lying inside the struct, and these structs are heap allocated. So this is why it has a pointer. But here it would need a pointer directly. Oh yeah, this is perfect. Now the only thing that I am wondering is whether this will get propagated in tasks correctly. Let me show you what I mean. Where are some tasks? Not this, but abstract modeling problem, control and data driven tasks. It's loading. Where are the tasks? Okay, here they are. As you can see, they're getting passed in the functions directly. For example, evens, odds. And this works as it is. But if I, for example, assign the odds to a local variable, I'm not sure whether that will give me an error. If it does, then I most likely need to extend the language with an extra operation just for the HLS C backend. Okay, let's try making an array. No, we actually cannot do that right now, but we can make an array literal. In Spiral we are using the prefix to start it. 1, I32, 2, 3, 4, 5, and actually those need to be semicolons. Yeah, this seems to be fine. Let's put it in a C++ compiler to see whether it works. C++ online compiler. Let's try this again. The last time this froze on us. Maybe it would work. Oh, main must return int. Cannot convert raise and close initializer list to int32 pointer. Here int pointer. This is annoying. Okay, let's do some vexing. Array lit. And what is the return like? Okay, we'll match the return. What is the return local? Not this. Right, I'm just going over the bookmarks. Array lit. Oh no, let's paste this. Array score generator. Array literals cannot return from the function end. I guess since we are added, we might want to do something to make it easier to create the locals. I mean to create uninitialized arrays. Oh, why is my cursor messed up? Okay, now I can go into this. Oh yeah, now we can copy paste this. Oh no, where is it? We can just put this here. I mean, like this. And then like this. AR. And in fact, just a second. Sorry, I'm doing some changes, and the problem isn't that these are on the right side, but instead I think the problem is that these constants are of the wrong type. Or maybe they aren't. Oh, what do you know? Oh, this is so annoying. Suppose I did something like this. 13. Let's approach this problem from a different angle. We'll take these two. There should all be errors. And we'll have to handle them in the bindings loop, just like macros. I mean, this is ultra annoying, but what can you do? No. VT, VI, okay. D, okay, let's match on D here. Match D with... You can see how annoying error is in CR, in C++ in this case. Then what are these to begin with? Data. Okay, this should be dv, in that case l yeah, data prevars lit, okay, lit, and then okay, where is the type of the array? Y array t. In fact, like this. Then now we need the arguments. Let in equals init. Wait, it's type V array. What? Oh, oh yeah, it really is. Okay. What is it complaining about now? Alright, it doesn't need this dv anymore. It doesn't require the return. And line s. How about this? Maybe just regular line. Okay. And this is the array literal. Raise cogener expected. Okay, we'll do the same thing for the array create. Array. Oh, not the inits, but oh wait, I meant to do this. And then instead of the inits, it should have the literal, the statically typed literal. Okay, match B delete lit x. Array sizes need to be no. In the HLS C backend. Size yes, this is it. As you can see, the C syntax is, neat at first glance, but once you try to implement it on a machine, you see how poorly designed it is. And they should have just gone with the Lisp syntax instead of this garbage. Okay, let's try publishing it. Oh yeah, this looks pretty nice. Let's pass it into the C++ compiler. Okay. Okay, this works. And the compiler is getting in our way right now. So let's also try this. How do I create an array? Okay, error. Actually, let me look into the core library I forgot how it's supposed to be done. Create, okay, create a size. Okay. A I32 create 128. Is it expecting a dimension maybe? I64. I mean, one of the things that makes arrays hard to handle in Spiral is having to put in these array dimensions. Because the .NET doesn't have them, that makes them a lot easier to handle. But I need to put this in because I have backends in multiple languages. Maybe we'll remove that in the future. Is this fine? I think it should be fine. Sorry, I'm a bit distracted. Oh, let's try this. Yeah, it's fine. The basic bitch arrays. But let me just show you what happens if the variable isn't known at compile time, only at run time. You'll get this error. Yep. Array sizes need to be statically known in the backend. Okay, let me pause. Okay, let's do one more test. For example, suppose the df function here does have a free variable inul inul q. Let's make it qva, and then we'll apply it to this, and then we'll try to create a closure. Let's see what happens. Wait, I didn't mean this. Does it work? QA. Okay, let's make sure it's used inside. Now we get an error. Is it the right error? The HLS C backend doesn't support closures due to them needing to be heap allocated, only function pointers. For them to be converted to pointers, the closures must not have any free variables in them. Oh yes, this is perfect. And suppose it is statically known at the compile time, then it won't be a problem. In fact, take a look at what happens. Right now, it won't even be instantiated, I think. Why is this happening? Sorry, I did make a mistake in how I'm getting the free variables after all. Let's take a look at the closure again. This, and this would in fact have not just the free variables, but pretty much all the Okay, let's print it out. What's going on? Let's do a print static a. If we build, let's look at this here. If we build it, string. So it so it is runtime. Okay, suppose I did this. Yeah, there's no way. Okay, suppose I did something like 1, 2, 3, I32. Yeah, it's getting converted to a runtime variable, but that shouldn't be happening. Oh yeah. It's because I'm using a let statement here. That ends up converting all the arguments to runtime variables. If I do something like inol join, all the functions get specialized. Then if I do QEA, what is getting compiled is this. Now if I try converting the static variable to a runtime variable inside the method body, what will happen is as you can see, it just makes this QEA here. Yeah, can I even assign this to a char? I mean, it complained about arrays before. Oh, let me try running this. Yeah, this way of assigning to char pointers is fine. Okay, now let's end the video here. I can't think of anything else that we need to add to the HLS C backend, so I think it's pretty safe to say that we have most of it right now. Whatever else we might need, we can just add it as we go along. We are in pretty good shape right now. What we can do from here on out is actually try programming FPGAs. What I'll want to do is try implementing the poker game on it and seeing how much it takes it to compile. I'm not sure. Okay, if it's something like an hour, maybe I can bear with it somehow, just barely. But if it takes days for something like a poker game, I'm not sure whether the FPGA adventure will go particularly far. I mean, what can I say? This is a pretty shitty timeline we're in. We don't have any advanced hardware. FPGAs would be a great fit for pretty much everything except, you know, the compilation issues with them. So at this point I don't have any choice but to take risks and see where that gets me. I think there are still some minor issues with the backend, but I can't fix them because they are tied to the other backends. So if it turns out that the FPGAs are really a great fit for what I want to do, and not just for Spiral, I'll get rid of the other backends and make Spiral an FPGA only language. And that's it for this video. Please like and subscribe, it really helps me out. Maybe I'll be looking for work in the future if the opportunities that I am pursuing right now don't pan out, so if you want to hire me for anything, don't hesitate to contact me. At worst, maybe I'll tell you that I will already have a job. And Yeah, that's about it. See you in the Stage Functional Programming in Spiral playlist.